Okay, let's talk a little bit about the graphing of these logarithm functions. So first of all, I know you are pretty comfortable with, or should be comfortable with, graphing something like this. Y equals 4 to the x. That's an exponential growth function. So we know that we could plug in numbers like -1, 0, and 1, and we would get 1/4, 1, and 4, giving us the exponential growth shape. Well, let's look at y equals log base 4 of x. Change it into its exponential form. The base is 4, the exponent is y, and the argument that it equals is x. Now what I want you to notice is that the x and the y have been switched. Now that should ring a bell to you, because when you switch x and y, you have created an inverse, right? So this is the inverse of an exponential growth function. Okay, and an inverse is a reflection across the line. We should have like a magical line, right, at y equals x. Everything is reflecting across that. So I want you to see in the picture down below that I graphed a logarithm right here. If you switch x and y, which is what I did in this chart right here, okay, the x's and the y's switch places, we end up getting a curve which down below on the low side actually starts close to the y-axis because that's the vertical asymptote, and then it goes up like this. This value right here is kind of important. It's the 0.10, just like this point over here was the 0.01. Okay, that's an important for all these logarithm functions because they all contain that point unless things have been changed or moved. But the vertical asymptote is x equals 0, commonly referred to on the street as the y-axis. But its actual name is x equals 0. And that would look like letter choice C down below, okay? Just graphing a basic logarithm function. Your other choices, A, that's your exponential growth. B, that's actually exponential decay. I wrote that equation, y equals 1/4 to the x. And over here, D is weird. That's a -1 being multiplied times the log function. We won't get into that one, but that's what happens when you do it. It flips over like that across the x-axis because you're changing the y values. Okay, now what happens when you graph both of them on the same one? So for instance, what if we graph this one in green and this one in purple? We get the choice that I circled, right? The growth function is in green, the logarithm is in purple. Not too much to tell you about there. Question 8, what happens when you move this thing, right? What happens when you slide it? Remember, if the change is on the inside, we always talked about how that went against your common sense. This actually goes left 8. So that's choice C. You can see that the pink or pinkish one had been moved left 8. Now, we're going to be asking you questions about domain and range, and maybe to highlight this a little bit more. Remember, I talked to you about smashing all the points down onto the x-axis and seeing how much of the x-axis gets covered. And what we would have is this for domain. Okay, everything bigger than -8, but not equal to, because that's that vertical asymptote. And according to MC Hammer, can't touch this. Now, if you take all these values and you push them up against the y-axis forever and ever and ever, looking for the range. Now, believe it or not, this thing's going to keep going up and up and up and up and up forever and ever and ever. I know it's going to go up slowly, but it will. So eventually, I will cover the entire y-axis. Therefore, the range would be all reals. How do I say that in interval notation? Well, here's how you do it. Okay. We want everything from, -8 to positive infinity, right? Positive infinity, way out here, right to the right. So notice that I used a parenthesis. Parenthesis means it's not equal to. Bracket means it is equal to, but you won't see a bracket on any of these. These are all parentheses. Okay, from -8 to infinity. Well, I know this is kind of hard to see, but like this is negative infinity down here for the y's and positive infinity up here. And if you were to identify the range, sometimes I even like, turn the whole thing. Let's see, for you, it would be like turn it this way. 90 degrees, right? Take a look at your graph, right? And then realize that all reals go from negative infinity to positive infinity. Never put a bracket on infinity because you can't grab a hold of it. Neither you nor anybody you know on this entire planet can. Nice try. You put a bracket on infinity, ooh, they will kick you out of parties so fast, it won't even be funny. Okay, so I've already written those things down. Vertical asymptote x equals 0, negative 8 to infinity, and negative infinity to infinity. If you haven't figured this out, the range is going to be the same every single time. I mean, you'll figure it out here in a moment. Okay, so notice that the 2 is on the outside of the function. Typically we write it on the other side. I'm trying to be all tricky here. But when it's on the outside, it goes up. It's either up or down, and it matches your common sense. So this graph has been moved up 2. Now, you're actually going to have to look at some points here to figure that out. But the only graph, since it is multiple choice, the only graph that shows up 2 would be letter choice A. And if you take a look at the domain, well, the domain isn't changing, right? It still starts out at 0 and goes to the right forever and ever and ever. And the range? Still negative infinity to infinity. What about that asymptote? Didn't change, x equals 0, because all you did was shift the graph up 2. That's not going to change that. Next. Question 10. Moving to the right 8. Remember, when it's on the inside, it's backwards. Oh, by the way, this is a common log, so that's base 10. Not that that's not the most significant thing in the whole wide world at the moment. But they do show you a couple points here, right? On the original. These are points on the original right here. That would be just plain old log x without the whole -8. But if you do shift it over 8 units, that's letter choice B. You can see the pink one moved over 8. The asymptote is now x equals 8. We're talking about 8 to infinity for the domain, right? And still negative infinity to infinity for the range. Like I said, that ain't changing. I'll let you write those things down. And 11. What if it's outside and it's negative? That means it's shifting down 5, right? So that is letter choice A, down 5. And you can see that if you're moving it down 5, the domain stays the same, right? 0 to infinity. The range is still negative infinity to infinity. And good old asymptote x equals 0. Ain't changing. Next. One last picture. Here's the function, and they're asking me to figure out what out of the multiple choice options. Is it a plain old logarithm function, base 5, or is it something else? Have they moved it up? Have they moved it right? Have they moved it left? Well, your only real choice would be either moving it up or leaving it alone, because left and right, you could see that, x equals 0 is still the vertical asymptote, so it hasn't been moved left or right, so those are kind of dumb options. And if you take the function, like letter choice A, that would be 5 to the y power equals x. Just plug in a couple x values, right? Like 0 and 1. And what you get, 5 to the 0 and 5 to the first. Then go over here and look at your graph. Hey, look, there they are. We know that we've got letter choice A. Okay, that's it for this Swyk. And I think you're ready for a test. I know you're excited about that.